Science Behind Throwing a Football by Damian Navarez. As the quarterback releases the ball, inertia is the greatest force acting on it. That is why it travels upward. As a football moves sideways throughout the air, its upward motion forces more air under the ball, which creates a buoyant force, which is why quarterbacks throw at an upward angle. When the football travels through the air, it always follows a curved or parabolic path because the movement of the ball in the vertical direction is influenced by the force of gravity. As the ball travels up, gravity slows it down until it stops briefly at its peak height. The ball then comes down and the force of gravity accelerates it until it hits the ground. When a quarterback throws a ball, their fingertips have to be spread out around the football. Then when they throw the football, their throwing arm is at a 90-degree angle in a throwing motion. When the quarterback throws the ball, they always follow through to give more power to the ball. Newton's first law of motion explains that an object at rest must stay at rest unless acted upon by an external force. In this regard, a passer's throwing motion becomes the external force that propels the football. In addition to throwing the football, the passer's grip and release causes the football to spin on its lateral axis, and he benefits from the aerodynamic of the ball's ellipsoid shape. Newton's second law states that the force on an object is equal to the mass of the object multiplied by its acceleration. If we apply this law to a football, it tells us that the amount that the ball accelerates depends on the force applied by the quarterback and the mass of the ball. Newton's third law of motion states that for every force applied there is an equal and opposite reaction force. An example of Newton's third law can be witnessed in the 49ers locker room. Picture a football helmet sitting on top of a player's locker. Even at rest, the force of gravity is pulling on the helmet, and the locker is pushing up on the helmet with a force of equal in magnitude. This keeps the helmet from falling due to the force of gravity. Newton's laws of gravity helps us understand why most short passes have less loft and arc than long passes.